Here are step-by-step instructions how to answer each question on the practice test. First, the first question should say minus 24x instead of minus 32. So then when I look at this, A and C are both perfect squares. That means this is a special case. Remember, A and C are the only two numbers that you look at for when you have a special case. So the square root of 16 is 4. That goes with my x. Square root of 9 is 3. So first I'm going to write out my two parentheses. And since I have a middle term here, then my symbol or my sign should be the same as my middle term. So it should be minus and minus. And this would be my final answer because I'm just asking you to factor, no solving. When I look at this problem, this is not A and C, so this would not be a special case. So when I look at here, what do they both have in common? What can you take out? I can take out a 4 and I can take out an x. When you take out, factor something out, that's like dividing each term by what you are taking out. So then I would have an x minus 4 left over, and this would be my final answer. Here again, I want to factor. This right here is my A, this right here is my C. My A here is 1, my C here is 100. Both of these are perfect squares, so this again is a special case. When I square root 1, I would just get 1 out. When I square root 100, I would get 10 out. So now here, there is no middle term. There's no B term. So if there's no middle term, you should have opposite symbols. So it should be plus 10 minus 10. That would be completely factored. First question, what do they have in common? What can you take out? Here they both have a 4 and an x in common, so I'm going to divide each one by 4x. That doesn't mean that's gone. You still have to write that part out. Add my 4x, and then when I take that out, I'm left with 3x, and 4x divided by 4x would just be 1. So this would be my final answer. First question, what do they have in common? What can I take out? There is nothing I can take out here. But when I look, this is my A and this is my C. Again, A is the number with the x squared. C is the number that's by itself. So this would be a special case. Square root and square root, that would give me 7x and 8, and 7x and 8. So then I think, okay, what should the signs be? There is no middle term here. Nothing's there, so they should be opposite signs so that the middle term cancels out. And here are my conjugates, because they're opposite each other, conjugates. So that would be my final answer. I have to solve this by factoring. So I'm looking for the solutions, but solving by factoring. So first thing I have to do is get it so it says equal to 0. So I'm going to have x squared plus 12x plus 32 equals 0. I have to add 32 to both sides of the equation so that I can have it equal to 0. And now I factor. There's no number out in front here, so I'm looking for two numbers that multiply to get 32, but would add together to get 12. If you're unsure, I would always write out all the factors of 32. But it should be x plus 4 and x plus 8. 8 times 4 adds to get 32 and multiplies to get 32 and adds to get 12. Now, in order to solve for x, both of these, x plus 4 equals 0, x plus 8 equals 0, and I would get x is equal to, here I'd have to subtract 4, so that would be a negative 4. Here I'd have to subtract 8, so it would be negative 8. So these would be my two solutions. When you are solving, again, you want to make sure to get this equal to 0. So I'm going to add x squared on both sides. When you are doing this, you want to make sure it's in standard form. Your x squared should come first, and then your number with your x, and then your number all by itself equals 0. Again, I do not have a number in front of my x squared. So two numbers that multiply to get 25, add together to get negative 10, be x minus 5, x minus 5. Now when you have the exact same thing inside your parentheses, you should get the same answer. So I'm only going to solve this once. So x minus 5 equals 0. I'm going to have to add 5 to both sides, so x is going to be equal to 5. Here I have to factor. So I'm going to solve this using the trig method. So I'm going to write trig down here below, divide by 5. Because in order to do the trig method, first I have to do a times c. So this would be written as x squared minus 13x minus 30. And now I'm going to factor this. So two numbers that multiply to get negative 30, but add together to get negative 13. Be x minus 15 and x plus 2. Because negative 15 times 2 would give me negative 30, and when I add those together, I would get negative 13. Now I have to remember my trick. I have to divide by 5 now. So I would have, this would simplify to be x minus 3, and this would simplify to be 5x plus 2 equals 0. Remember, you were solving here. So what you should be doing now is setting both of these equal to 0. X minus 3 is equal to 0, and 5x plus 2 is equal to 0. So this first one will give you x is equal to 3 because I have to add 3 to both sides. The second one, I have to first subtract 2 from both sides, and then I would have to divide by 5. So my answer would be 3 and negative 2/5. What do they have in common? What can I take out? I can take out a 5, leaving this to be x squared minus 8x plus 7 is equal to 0. Now I can solve this. 5 would be x minus 7, and x minus 1 equals 0. This 5 right here is not going to change my answer. So either I can put the 5 with the first, or just kind of forget about it. Because x minus 7 equals 0, and x minus 1 equals 0. When I solve these, I'm going to be adding 7 and adding 1 to the other side. So my two zeros would be x is equal to 7 and 1. That would be my final answer. Same thing here. What do they have in common? What can you take out? I'm going to take out a 2. So I'd have 2 on the outside, x squared minus 5x plus 6. So two numbers that multiply to get 6, but add together to get a negative 5. Those two numbers would be x minus 3 and x minus 2. So just to reiterate what I said from the last problem, I could put this 2 with the x minus 3 right here and put that equal to 0, and then have x minus 2 equal to 0 and solve both of those. If I'm going to solve both of those, first I'm going to divide this whole thing by 2 to get rid of that, and then I would be left with x minus 3 is still equal to 0, because 0 divided by 2 is still going to get me 0. And then add 3, so I'd have x is equal to 3, and this one, if I solve for x, I have to add 2. X is equal to 3 or 2. Here I have to solve the equations. The first thing I'm going to do is divide by 4 on each side, because I want to get x squared by itself. So I have x squared is equal to 6. And now I have to undo the squared, which is taking the square root of that. So I have x is equal to, square root of 6 cannot be simplified any further. There's no perfect factors of perfect squares in there. My answer would be positive or negative square root 6. Remember, when you are solving for x and you take the square root of a number, you have to have the positive or negative. Same type of thing here. First, I'm going to divide by 8, divide by 8. I would simplify your fraction here. 50 divided by 8, both of these can be divided by 2, which would give me 25 over 4. Now, just like the other one, I have to take the square root and take the square root. So x should be equal to positive or negative. I could split this up to the square root of 25 or the square root of 4 and be 5/4. So you need to have the positive or negative 5/4. Here I have to use the quadratic formula. In this case, my a is going to be equal to negative 1, b is going to be equal to 6, c is going to be equal to negative 3. So when I write this down, I have opposite b plus or minus the square root of b squared minus 4 times a times c all over, so including this part too, this whole thing is divided by 2 times a. Now if I were to simplify that, you just want to simplify this portion first, and you get negative 6 plus or minus the square root of 24 over negative 2. So now I think, okay, there's a perfect square in 24. 4 times 6 is equal to 24. So I could rewrite this as, if I take the square root of both of these, negative 6 plus or minus the square root of 4 is 2. Square root of 6 I cannot do. Divide by negative 2. Here you can do this one of two ways. You can either simplify with your fraction or factor on the top. I'm going to simplify with fractions, so I have a negative 2 over, or negative 6 over negative 2, plus or minus 2 over square root 2. Now when I completely simplify this problem, this right here simplifies to 3, and I have my plus or minus. When I have this negative 2, this is still going to cancel each other out. Because I have a plus or minus, it still takes care of both positive and negative. So the 2's will just cancel out here, so it would just be 3 plus or minus 6. Quadratic formula, a is equal to negative 2, b is equal to negative 6, c is equal to 5. So I have my opposite b plus or minus the square root of b squared minus 4ac all over 2a. And when I simplify this, I would have 6 plus or minus the square root of 76 over negative 4. And again, you want to find out your perfect squares. In this case, it'd be 4 times 19. So I have to take the square root of 4. To have 6 plus or minus square root of 4 is 2. Take the square root of 19. You can't do that. And then divide by 4. The other way that you can factor this or simplify this further is, what do 6 and 2 have in common? You can take out a 2 here and be left with 3 plus or minus the square root of 19, because you're factoring out a 2, divided by negative 4. And now, because it's being multiplied, you can simplify this. So your final answer would be 3 plus or minus the square root of 19 divided by negative 2. Right here would be your final. Using imaginary numbers, remember I is equal to the square root of negative 1. I squared is equal to negative 1. So I could rewrite this as negative 1 and 4 and take the square root of both of them. Square root of 4 would give me 2. The square root of negative 1 would give me I. So my answer here would be 2i. Same type of thing here. I'm going to rewrite this, but I'm going to write it with a perfect square. I can have square root of negative 1. That's going to take care of my negative part. And then two numbers that multiply to get 72 would be 16 and 2. The reason why I'm picking 16 is because 16 is a perfect square. So I could rewrite this as 4, that's the square root of 16, I, that's the square root of negative 1, square root 2. Remember, you could also have your answer like this, as long as I can see clearly that the I is not underneath the root. When I am simplifying with I, adding, subtracting like terms, here this is adding, so the signs are as is. So now I'm looking at like terms. These are my real, these are my imaginary. So I would first do 8 minus 5 would give me 3, and then I have a positive 6 plus 10i would give me plus 16i. And that would be my final answer. A little bit different here. This is subtracting. You have to first distribute your negative 1 into the equation. So I'd have 7 minus 2i. That does not change here. Negative 1 times 9 would give me a negative 9. Negative 1 times 3i would give me a minus 3i. And now it's the same thing as the last problem. Here are my real numbers. Here are my imaginary numbers. So 7 minus 9 will give me a negative 2, and negative 2i minus 3i would give me a negative 5i. So this would be my final answer. Here there's no sign in between. If there's no sign in between, this is where we have multiplying. You only FOIL when you multiply. So I have my first two terms. So 9 times 5 is 45. I have my outside terms. 5 times 2i would give me plus 10i. I have my inside right here. These two terms multiplied together. Negative 7 times 9 would give me a negative 63i. And I have my last two terms. Negative 7 times 2 gives me negative 14, and I times I gives me I squared. So when I'm looking at this, I'm going to combine my like terms here. So I have 45, then minus 53i. And I'm going to write minus 14. Remember, I squared is the same thing as negative 1. So when I simplify this right here, this is a 45 minus 53i plus 14, because this is a negative 14 times negative 1. So my final answer would be 59 minus 53i. Here I do not want the I on the bottom. No, there's no adding, subtracting here, so it's just getting rid of the I. So in order to get rid of the I, to make it real, I have to multiply the bottom by I. Whatever you multiply the bottom by, it has to be the same thing on top. So I'm going to put this in parentheses. So on top here, I have to distribute my I to both terms. So this would be 3I minus 8. And this becomes I squared over 4, and I times I is I squared. So I could rewrite this as 3i minus 8 times negative 1 over 4 times negative 1, because I squared is equal to negative 1. So my final answer here would be a positive 8 plus 3i. Right here, this becomes positive because of negative and negative, over negative 4. 4 times negative 1. And this right here would be my final answer. Here I have to use my quadratic formula. Opposite b, there's no number here, so that's like in 1, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now if I simplify this right now, that is equal to negative 1 plus or minus the square root of negative 3. This cancels out, so I'm not going to write that portion. You should never write your answer with a negative inside the root. So my final answer would be negative 1 plus or minus I square root 3, or else you could have the I on the other side. And that would be my final answer. Here I want to solve for x. So I'm going to first subtract 9 over on both sides of the equation. So 49x squared is equal to a negative 9. And then divide by 49. So I have x squared is equal to negative 9 divided by 49. How do I get rid of something squared? I have to take the square root. So my answer here would be x is equal to, this negative would make an I out in front, and I could rewrite the square root of 9 over the square root of 49, which is equal to 3/7. Or, a little better, how to write this is, you also need your plus or minus. Plus or minus 3/7 I. This is how you should write your answer. And those are the answers to your practice chapter 4 part 2 test.